In this video, we will learn about the scope resolution operator and how to work with it in C++. The scope resolution operator is 2 colons. This operator has several uses. The first is differentiating between the global and local variables in our program that have the same name. For example, let's create a string variable named s that we set equal to the string global string s. Then, inside of the main function, we will create a string variable s set equal to the string value local string s. Note that it is okay that we have defined 2 strings named s, because one is in the global scope, outside of any function in the top level code. The other is inside of the main function, so it has local scope and only exists inside of that function. Let's output the result of : s to the console. Then we will print out a new line followed by the value of the string s. When we run the code, notice that global string s was referenced when we used the scope resolution operator, and local string s was referenced when we just typed the name s. Another use of the scope resolution operator is to be able to define a function outside of a class. For example, let's create a class named example. Inside of here, we will declare a public function with a void return type named function1. Notice that we are just putting a colon after the parentheses and not adding any body for the function. To define the function body later on in our program, we can go outside of the class, type void example, and then use the scope resolution operator and specify the name of the function, which is function1. Inside of this function, we will output the string function1 was called to the console. Inside of C++'s main function, we will create a variable of type example named example. Then we will call example's function1 function. When we run the code, notice that the string function1 was called was output to the console. Another use of the scope resolution operator is to access a static variable. For example, let's create a class named example, inside of which we will have a public static int named num. Then, outside of the class, we will specify int example, then use the scope resolution operator, and then assign the num variable a value of 5. Inside of the main function, we will output the value of num to the console. When we run the code, notice that 5 was output. In this video, we will learn about abstract classes and virtual functions, and how to work with them in C++. An abstract class is a class that can't be instantiated, but can be used as a base class. We use abstract classes when we have a generic class we want to create, and want other classes to extend this class, but not create an instance of the abstract class directly. A good example of an abstract class is a shape. If someone gave you a pen and paper, and asked you to draw a shape, how would you know which shape to draw? Shape is an abstract concept. There is no concrete definition of a shape. Now, if I asked you to draw a circle or a square, etc., you would be able to do so. Let's create a class named shape. Inside of this class, we will declare a public virtual void function named draw that we set equal to 0. The equals 0 part is a special type of syntax that marks this function as a pure virtual function. This is a function that the base class needs to override. Notice that if we try to instantiate a shape named s and then run the code, that we get an error. The program recognizes that shape is an abstract class and does not allow us to instantiate it. Let's create a class named circle, which extends the shape class. Inside of here, we will override the draw function, inside of which we will output the string circle drawn to the console. Then we will create a class named square, which extends the shape class. Inside of here, we will override the draw function and output the string square drawn to the console. Time to test our code. Inside of the main method, we will create a circle named c and then call its draw function. After that, we will output a new line to the console. Then we will create a square named s and then call its draw function. When we run the code, notice that circle drawn and square drawn were output to the console. In this video, we will learn about generics, aka parameterized types, and function templates. Generics are an important concept in programming. They make it possible for us to have a method that accepts different types of arguments when the function is called. Programming with generics promotes code reuse and avoiding code bloating by many overloaded versions of a function. Function templates are closely related to the concept of generics, and they enable us to write a single function that works with different data types. Let's look at an example of these concepts in action using C++ code. First, we will use the template keyword. Then comes a pair of angular brackets. Inside of here, we will use the type name keyword and can specify any name that we want for the type. A typical convention is to use a capital T. Next, we will create a function with a return type of T named generic function, which takes in one parameter of type T named param1. Inside of this function, we will return param1. Time to test our code. We will output the result of a call to generic function with the string ABC passed into the console. Then we will print a new line. Next, we will output a call to generic function with the integer value 4 passed into the console. Then will come another new line. After that, we will output a call to generic function with the Boolean value of true passed in. Notice that the same function was used with 3 different types of arguments passed in: a string, an int, and a bool. When we run the code, notice that ABC was output, then 4 was output, and then 1, which represents a Boolean value of true was output.